Stand at the lip of a waterfall and shout upstream. If the river runs slower than sound, your voice climbs back against the current and somebody upstream hears you. Now speed the river up. Push it past the speed of its own sound. There is now a line on the water, you can walk to it, you can mark it with a stick, and beyond that line no shout can ever return. Sound made downstream of it is swept over the edge. Sound made exactly on it crawls forever without arriving. That is a horizon, not made of collapsed stars, not of curved spacetime, made of nothing but a moving medium and a finite signal speed. And here is what makes it more than a curiosity: a horizon like that is expected to glow. So this chapter asks whether the chakra substrate can grow such a line, and whether the line glows. The answer forces a correction the author makes out loud about his own earlier draft. A substrate whose signal speed merely varies in space traps nothing at all. You have to make it flow. One thing before we begin. Advaita Chakra Theory is a speculative, exploratory framework, not established, peer-reviewed physics. Much of what follows is honest conjecture that still needs validation. Watch it in that spirit as ideas to test, argue with, and refute. After chapters 6 and 7, the temptation is enormous. There we let the emergent light speed vary from place to place. C effective becomes C effective of X, and we showed that this bends rays exactly like a graded index lens with an exact optical curvature. So the obvious guess is find a region where the cone speed dips low, and surely light gets stuck in the dip. It does not. Look at the line element a varying speed produces. The time component is -1 everywhere, with no cross term between time and space. Physicists call that ultrastatic, and the word is doing real work. A horizon is a surface where a time direction changes character, where the relevant norm crosses through zero. Here that norm is the constant -1. It never crosses, and field theoretically the same verdict arrives from the other direction. To make particles you need the positive frequency and negative frequency descriptions on the two sides of a surface to mix. For a background that is time-independent and has no flow, the Hamiltonian stays diagonal in the instantaneous modes, and the mixing coefficient beta omega, the number that counts created pairs, tunnels to zero. A well in the cone speed gives you a scattering amplitude, not a thermal one. And the group velocity is strictly positive everywhere, so a ray that starts outward stays outward. There is always a way back. I want to slow down here, because this proposition is not an abstract exercise. It is a retraction. An early draft of the black hole thread in this corpus internally, the 12th ACT document, reported a thermal-looking spectrum coming out of a static cone speed well. It looked like Hawking radiation. It was not. What the calculation had actually found was a scattering artifact of a sharp profile, a gray-body-like transmission dip, mistaken for a Planck curve. Fit a smooth falling shoulder with a thermal template, and you will often get a respectable-looking temperature out. That does not make it emission. The corrected statement is the flat one you just saw. A static speed map is a lens, and a lens does not radiate. So the chapter proceeds by elimination. The suspect everyone reaches for first is knocked out with a proof, not with a hedge. And the elimination is informative because it names what was missing. The reason the ultrastatic metric fails is that it has no off-diagonal term between time and space. No cross term means no frame dragging, and no frame dragging means nothing is being carried anywhere. That missing cross term is the one ingredient the entire geometry half of the corpus had left out. Chapter 6, Chapter 7, and Chapter 13's analog cosmology all omitted it. The substrate has to move. So we endow the locked substrate with a coherent drift. Call it U of X. Physically, this is a state in which the goldstone condensate itself streams, a uniform phase gradient advecting the order parameter, so the local frame in which the cone looks isotropic is moving relative to the lab. It is a legitimate configuration of this substrate, but be clear about its status. It is put in. The flow is an imposed background, not something the geometry sector generated for us. With a drift, the line element finally acquires the cross term it was lacking. The natural way to write it is Painlevé Gullstrand form. The time part becomes the cone speed squared minus the flow speed squared, and there is a genuine cross term between time and space proportional to the flow. Now count velocities in the lab frame. A mode moving with the current travels at the flow speed plus the cone speed, a mode fighting the current at the flow speed minus the cone speed. The horizon is exactly where that counter-propagating branch is brought to rest, where the flow speed plus the cone speed equals 0. Downstream of it, where the flow exceeds the cone speed, even the fastest counter mode is swept along. that region is trapped. A sonic black hole here, since our quanta are phonons of the Goldstone, a phononic one. And none of it is new physics. It is Unruh's acoustic horizon condition from 1981, read on the single Goldstone of part 1. Once you have the horizon condition, the temperature follows almost mechanically. Zoom in on the crossing point. The trapping combination, flow plus cone speed, passes through zero there, so near the horizon it is just a straight line, a slope times the distance from the horizon. That slope is the surface gravity, kappa, literally the gradient of the trapping combination, evaluated at the horizon. A steep crossing is a sharp horizon, a gentle crossing, a soft one. And the emission temperature is the Hawking value, kappa over 2 pi in units where h bar and Boltzmann's constant are 1. Why that follows is worth saying in words. Making the trapping combination linear in position is exactly the configuration whose in-to-out mixing ratio is thermal. It is the same near-horizon algebra that gives an astrophysical black hole its temperature, and it does not care what the medium is. This is the kappa of our master notation, kept deliberately distinct from the on-site locking constant k. Now, one caution, stated plainly because the chapter states it plainly. These equations follow from the geometry of the flowing background. But no explicit mode-by-mode beta omega has ever been computed for the rotor lattice with an imposed flow. The temperature is read off from the universal near-horizon form. It is not the output of a first-principle substrate scattering calculation. That gap is the frontier of this chapter. Here is where the substrate leaves a mark. The Goldstone dispersion is not the clean relativistic relation omega squared equals c effective squared times k squared. The lattice has a finite spacing A0, that is axiom A3, locality and finite spacing, and a finite spacing turns a derivative into a second difference, which adds a quartic tail minus 1/12 times k squared times A0 squared inside the brackets. It is the same minus 1/12 that shows up in the double slit chapter and everywhere else the lattice speaks. The sign matters enormously. It is negative, which makes the substrate subluminal at high wave number short wavelength modes travel slower, not faster, and that is precisely the ingredient that cures the trans-Planckian problem of Hawking radiation. On a strictly relativistic horizon, the outgoing modes trace back to in-modes of arbitrarily large blue shift. The calculation reaches below any conceivable microscopic scale. On a lattice, the group velocity is capped, so a mode that would have been blue shifted without limit is instead turned around at a finite wave number of order 1 over the spacing, and converted between branches. The Hawking flux survives. It never depended on the ultraviolet completion. But it is now modulated by the interference between the mode's two turning points. The result is a thermal spectrum multiplied by 1 plus epsilon times the cosine of an accumulated action plus a fixed phase, with the depth epsilon scaling as the spacing squared. A small oscillatory ripple, riding on a Planck curve. Now the honest passage, and it is the most important one in the chapter. That ripple is tagged standard, not derived, and the chapter says out loud why. It is the generic signature of any dispersive analog horizon, Corley and Jacobson's 1996 lattice result, reproduced identically by superfluids, by Bose-Einstein condensates, by surface water waves in a flume. It is not a chakra signature. The corpus explicitly retracts an earlier uniqueness claim here. The ripple tells you that dispersion exists at some length scale. It does not tell you the medium is a rotor lattice rather than a Bose condensate. And there is a second boundary to draw, even more often blurred. An analog horizon is not an astrophysical black hole. No collapsed star, no singularity, no event horizon in the general relativistic sense, just a trapped region for phonons in a moving medium. Analog Hawking radiation is therefore not evidence about how real black holes evaporate, and detecting it would not settle the information problem. What the analog tests is kinematics, whether a horizons plus a quantum field yields thermal pair creation. Nothing about the dynamics of Einstein's equations is being probed, and this theory does not have Einstein's equations anyway. Chapter 12 closed that verdict as Lorentz violating scalar tensor, and this chapter inherits it in full. One nearby effect is worth separating out too. An accelerated detector sitting in the flat cone also reads a temperature. That is the Unruh effect, tied to an observer's word line rather than to a trapped region genuine, but a different mechanism, and not what these equations compute. Let us make it concrete, because the numbers land in a surprising place. Take a quasi-one-dimensional flowing Goldstone condensate, the substrate analog of the sonic horizons people actually build in laboratories. Let the sound speed be 0.5 millimeter per second, and let the flow accelerate smoothly from subsonic to supersonic across a ramp 3 microns long. The surface gravity is roughly the sound speed divided by the ramp length, about 170 per second. Feed that into the Hawking formula and the temperature is about 2 times 10 to the minus 10 Kelvin. A fraction of a nanokelvin, exactly the regime in which these horizons are studied. Now the ripple. The dispersive length here is the condensate's own healing length, about 1.5 microns for rubidium-87 at this sound speed. Against a horizon smoothness of 3 microns, the modulation depth goes as the ratio squared 1.5 over 3 squared, which is about 0.25, 25%. Compare that to detectability. Correlate the measured spectrum against the known cosine template across n independent frequency bins, and the match filter floor is sigma times the square root of 2 over n, about 3.5 times 10 to the minus 3 for the reference numbers. So the ripple in a real condensate sits nearly 2 orders of magnitude above the single-shot floor. Soften the ramp to 50 microns, and the depth falls to about 10 to the minus 3. Back under the floor, then you stack runs, and the floor drops as 1 over the square root of their number. Verdict. The graded cone is acquitted with a proof. A static speed profile has a globally time-like time coordinate, no trapped surface, and a mixing coefficient that vanishes. It lenses, it does not radiate. Add a coherent flow and you do get a horizon where the flow plus the cone speed crosses 0, with surface gravity the slope of that crossing and a Hawking temperature of kappa over 2 pi. Those are Unruh's acoustic black hole relations verbatim, with our one Gullstrand playing the phonon, and the credit goes where it belongs. The dispersive ripple is real and large in a genuine condensate, but it is Corley and Jacobson's, not ours, and it fingerprints dispersion rather than the medium. 2 things here are asserted rather than computed. The flow is imposed, nothing in the geometry sector produced it. It is put in by hand to supply the cross term a static cone speed lacks, and whether a drift strong enough to form a horizon could arise dynamically from substrate evolution is open. Second, no explicit mode-by-mode mixing coefficient has been computed on the rotor lattice with a flow. One object would close both gaps, a full Bogoliubov computation on the flowing rotor lattice, giving beta omega and the modulation depth straight from the microscopic couplings. No paper in the corpus provides it, and the throughline holds, 1 substrate, 1 goldstone. The mode that was light in part 2 and the guiding field in part 6 is the Hawking phonon here. Same mode now made to fall. Next, take that ripple into a concrete Bose-Einstein condensate proposal and watch it match the condensate's own dispersion to 9 digits, a self-refutation delivered by the author on the record. A word of acknowledgement. This work was inspired in part by the non-dual teachings of Sri Narayana Guru, that the creator, the creation, and the substance of creation are fundamentally one. Symbols from the Hindu tradition, the Sudarshan chakra and the Shivalinga, suggested the analogies behind the chakra model. They are acknowledged as philosophical and symbolic inspiration. The physics stands on its own. Thank you for watching. If this made you think, please like the video and subscribe. It genuinely helps this work reach the people who will argue with it properly. And do leave a comment, tell me where you think I am wrong. Every chapter in this series names its own kill tests, and the objections are the point. The book and the next chapter are linked below. Until then, one substance and how far it reaches.